Hello, everyone. Today I'm going to give you a look at this crazy archtop guitar that I built a long time ago. I started this in 1979 and finished in 1980. I learned a lot from this guitar. This was a test that I built because I had an order for a 7-string classical strung archtop guitar. And before I really wanted to accept the order, I wanted to make sure that I could build such a thing because I didn't really know anything about classical strings except that they were very low tension. In fact, they're about half the tension of a light set of phosphor bronze strings that I was familiar with and building for. So I felt like I was on thin ice, and I decided that it would be prudent for me to build a test or sketch guitar that was not designed to be sold and that I could stretch out and learn some things from. So I decided while I was doing it, I would take the opportunity to throw on some other features that I was curious about. One of them is, you can see this guitar is built with overhanging edges like the instruments from the Violin family. This is an old design. It's from Andrea Amati in 1565 when he designed the first violin. He designed it with overhanging edges. Now the bowed instruments that came before the violin, the viol family, didn't have this overhanging edge feature, and consequently they were very difficult to repair. They're thin and fragile. Of course, there was no humidity control back then, and instruments were easy to hurt and very difficult to repair. So one advantage of this overhanging edge is it gives you a little margin for error when you're putting things back together. So if a top or back needs to be removed for repair or modification, then you have a little bit of margin for error when you stick it back together. If the parts are changing shape a little bit, you're going to be forgiven some of that. And indeed, it's why a lot of the members of the Violin family that are hundreds of years old have survived and still can give good service to modern professional musicians after all these centuries. So the overhanging edge is good for repairability and therefore longevity. And I was always curious as to why it wasn't included in guitar making, and I thought I'd give it a try. So that's something I'm still using. I also decided that it would be fun to go study with some violin making people, and I found through the Catgut Acoustical Society, I found a wonderful person named Carleen Hutchins, who was a charismatic spearhead kind of force of nature in the discovery of violin acoustics, and she and her confederates, including the brilliant Norman Pickering, who I also came to know, were devoted to studying old instruments and trying to figure out what made them tick and how to make modern instruments that were, if possible, improvements, at least the equal of these old instruments from the early Renaissance. So, studying with Carleen, I came to decide that I wanted to make a very thin set of plates for the low tension classical strings, and I wanted to see how much flexibility and volume I could get out of this instrument. So the plates are very light, just 2 or 3 millimeters thick. Sometimes it's less. On the back, the perimeter is about 1.5 millimeters thick. And I think if you look here, you can see when I push on the bridge that the top is moving pretty easily as I rock it back and forth. Anyway, it's a light instrument. The whole thing, complete with tuning pegs and a metal tailpiece, weighs 3.3 pounds or about 1.5 kilograms. While I was at Carleen's, I borrowed her test equipment, and this is the results. Photos that we took that day in 1980. these are the frequencies, and then these are the patterns of the dust, or I can't remember, I think it was glitter. Glitter's a mess, use dust. They liked glitter. And I wasn't sure what these patterns meant, but Carlene assured me that their cellos look just like these patterns when they're all tuned up and they're happy with them. So they have these two parabolic forms that are pointing towards each other from the ends of the instrument, and then also some long lines along the edges. So she thought these were excellent patterns, and as you can see, I tuned the two plates. Here's the back plate and the top plate. I tuned them to the same frequency, which happens to be a D flat. And then after the sound holes were cut, it moved to an A. And then after the brace was added, it moved to a B. You can see one of the things that we hoped to achieve was to get the pattern to go through the brace at this ring mode or fifth mode of vibration. So I was able to do that by graduating the brace properly. Now, I didn't use the test equipment in order to do this, where I decided to stop. This was just a check to see what I had done. Anyway, there it is. I put the instrument together. Again, very light construction. I try to use a lot of clues from the bowed instrument world construction. So if you look in here, you'll see that the lining is a solid piece of bent willow. So it's not curved and it's not very big either. Like guitar lining is quite large. And this is, I don't know, maybe 4.5 millimeters wide by 7 millimeters, something like that. And then carved down to a smaller shape, but with a knife. This guitar ended up being called, I named it Frankentop because I ended up doing so many other things to it that changed it over and over again. So when I first strung it up, that's the original neck. So here's a 7-string neck. I had just a dovetail neck joint that was actually just a pressure fit. It wasn't glued on, but it held fine. And we tried all kinds of different strings on it, and I never felt like it was really working right. And then somebody dropped it and it got broken. I lost interest in it. Years later, I patched it and put on a different neck. And then in 2005, I patched it again and used it as a test bed for my first carbon fiber reinforced neck with a pin, which you can see here. That was the most recent embodiment of a test bed. And that's really what this guitar has been, is just a series of discoveries. I never felt that it was a successful guitar as a nylon string guitar. And as I mentioned, I had put only one bar in here on the bass side. And this was before I really understood how the violin family instruments worked. And I was ignorant to the extreme difference in the string's behavior, whether it's bowed or plucked. Anyway, at some point I took the top off and put in a lightweight X brace, which is what it has now, stuck the top back on, courtesy of the overhanging edges. And right now it's got a new bridge as of today because it now has a new life. I had the guitar strung up with light gauge strings, I guess 11s or 12s maybe, put a 6-string neck on it, which of course was the neck that I built to test my carbon fiber neck pin design in 2005. So that's when the guitar got stuck back together. But I still didn't think it was a very good guitar with steel strings. It sounded okay, but I didn't like the sound that it made when you played it hard. It seemed to sound startled or overdriven. And then I met a fine guitar player named Elden Kelly, and I said on a whim that maybe I'd just send him the guitar without the steel strings, and he sent me his favorite classical strings, which I put on, and it turns out that it's a pretty good guitar after all, as you'll find out when you listen to Eldon's recordings of this guitar. As I mentioned, today I made a new bridge for it. This is a taller bridge of my new thinking. This is the bridge that it replaced that was on there earlier, and you can see it's quite a bit taller bridge design. This is about 50% higher than that, so this is about 25 millimeters, and that's about 38 millimeters high. And I think the guitar has more power. It's well balanced, and it's got a nice mid-range, pretty trebles. So a couple other things. We have an aluminum tailpiece here that was designed for another instrument. So this is kind of a hodgepodge of stuff. Here's my original tailpiece design. This was a takeoff from the gamba instrument family, and gamba was the precursor to the violin family. What I did originally for the tailpiece was this piece of rosewood was longer, it had a notch in it, and I had just a bar of wood with 8 holes in it, 2 holes for string that came back here around this pin and held it, and 6 holes, of course, for the guitar strings. And the idea of that was that I could change the afterlength. The violin makers call this distance the afterlength. So these afterlengths can be tuned, which of course they're not now. But anyway, that's something that violin makers talk about and think about a lot. Doesn't seem to be that important for guitar makers, but maybe it is, and we'll find out a little bit about that later. Right now, what I was going to do was get the neck off and try and put a longer fastener in there. And this is one way of showing you how the neck joint works. So what happened was when I first had the guitar together, this distance from the end of the pin to the top was about 600 thousandths. And now it's very nearly, well, it's a little over an inch. So I thought that would be okay because, as I mentioned, the string tension is so low that really the guitar doesn't see a whole lot of force. But when I raised up the neck this far, I ran out of adjustment. And so now I thought it would be fun to use this as an excuse to show you all how this works, and maybe fit in this longer adjusting piece of hardware. Now this piece of hardware is a kind of an unusual set screw, and it's a lot like you can think of it as an inside-out turnbuckle. So let's have a look at this. This is a set screw with a socket at both ends. We can use it either way. And one end is a right-hand thread, and the other end is a left-hand thread. They're both the same pitch. When you turn it, it either draws together or spreads the two things that it's threaded into. That's how it works. So let's see. We'll give one more. Try and hold all this stuff together while we do this. Of course, these nylon strings are really stretchy. And I must confess that I have very little familiarity with anything, any kind of guitar that has nylon strings on it. Okay, so we're going to take off this tailpiece, just held on by one 1/4 inch screw. Okay. Well, it's going to be fun to get back on. All right. So now we can see the end of the pin and this little bitty screw. So we think that this longer screw is actually going to save our neck here, literally. Let's see. I got that the wrong way around. Oh, you can see that there's a truss rod in this guitar, an adjustable truss rod, which is a simple compression rod, the kind I think is the best kind. Which is the original Gibson design. Now I put some paraffin wax on this screw. Just to make it easier to adjust. Okay. When I was first doing this kind of neck joint, I was worried that I would have to hold a very close tolerance between the pin and the socket that it goes into, but it turns out that it doesn't really matter because the strings are what holds the whole thing together. And turns out it works pretty well. I don't know if I'm going to be able to get this back on. What do you think? Anybody betting on this? I don't know. I don't think so. I have to take down some tension. Again, nylon strings are new to me, and it's kind of funny because I thought all these years ago that this was going to be a lot of fun to play with these strings and see what I could do, but as it turned out, I never thought I'd succeeded at this. So I didn't go down this rabbit hole way back when. Oh boy, I don't know. Yeah, I think I'm going to have to stick this in the vise to have any chance at doing this. Just trying to save some time by not playing with these rubber strings. All right, wish me luck. Thank you for your good luck wishes. Seems to be working. That's good. Well, I'm happy that worked. See what a quickie project this test neck was. I didn't even bother with a headstock veneer. It just has the plain and very beautiful fine-grained Douglas fir neck that forms the neck core exposed. Oh, by the way, these are Spurzl locking tuners from way back when. And it turns out they work famously with classical strings. And the trick to making this work turned out to be to hold the neck firmly in this vise. I know not everybody has that vise, but at any rate, what I was doing was holding the neck firmly and then grabbing the string with a plier and yanking on it as hard as I needed to get it to be darn near tuned up when I clamped the locking mechanism. That seemed to work pretty well. Now, so normally classical guitar pegs have really bigger posts than steel string pegs have because the strings are so stretchy and need a lot of winding to take the stretch out. Oh, look at that. So now we have restored the ability to adjust the action with a wrench, which is really nice. And before we hear this guitar, let me point out a couple of other quick things. One was that with an overhanging edge, obviously you're not going to use binding on the guitar because binding means you cut into both the top and the side. So instead, like the violin family, I used Purfling, and what I did was glue up 5 layers of veneer like this, and then I clamped this in my vise in the bench and pulled this through and cut off a strip, a thin strip, that I glued into a trench that I made. And I designed and built this little tool to make that trench, or purfling groove as it's called. And this is, there's 3 pieces of metal here, as you can see, 1, 2, 3. And this first part here is a foot that regulates the depth of cut. And then the second part is a double knife, one edge on each side. So this knife has two cutting edges, one inside the groove, one outside the groove. And then at the back end is a little plane blade that takes a chip that's defined by these two knives on the side. So depth regulations, and then so this is related to the depth of the cutter. And then these two little knives to define the width of the cut. And then here's this is ebony, this part, and then this is lignum vitae with a little screw so that I can change the distance from the edge of the plate to the purfling groove. And so you just manipulate this until you get the right depth, and then you have a purfling groove. Now the violin makers have a way to do this that's quite similar, but it's not one tool. So I thought this was a innovative improvement that made it better to cut this tricky little groove here. In practice, of course, there's a constraint on the depth, the depth of this groove. So if here's our plate and the groove, and then here's the lining, and here's the side. You can see that when you cut this groove, you seriously reduce the dimension of the plate where the groove is. And you'll also notice that the inside of the purfling groove is designed to be coincident with the edge of the lining. And so what that does is it diminishes the thickness of the plate by about half. And those of you who have been paying attention to what I'm talking about know that there's a cube difference in stiffness between a plate that's this thick and a plate that's that thick, which means that the creation of this groove is going to greatly weaken the plate right around the perimeter where the lining is. And that's a big deal, and it helps you get better bass response. Okay, so that's part of the purfling story. And the other part of the purfling story is that the purfling tends to limit the amount of damage that you can do. So if you put a force, you drive your instrument into the edge of a table or something by mistake, and it applies a force here. If this piece of spruce cracks off, the purfling will limit the damage, hopefully. And so it won't just make a big crack and bust the whole plate up beyond repair. In fact, what happens after these old violin family instruments survive for a long time is that at some point the edges will get so beat up over the centuries that they'll be repaired in the following way. The builder will remove the plate with the damaged edges, then they'll cut away material to make a nice even gluing surface, and then they'll glue in a new piece of wood here, and then they'll glue in another piece of wood here. And you can see, when you look at old instruments, if you can see a glue joint right here, as you often can, you can tell that this repair, or really reconstruction, has been performed. And it's one of the reasons that these old instruments can continue to survive in the world where tables are knocked into by musical instruments. And the whole process, this process of repair, or restoration really, is called re-edging. And so that is, you reestablish this edge, which can be thought of as a sacrificial bumper to some extent, since it's not really involved in producing sound, but rather as a margin for repair and as a way of absorbing injury without really damaging the way the instrument functions. That's my take on the edge story. Oh, and also the violin makers that I respect and know, same group, all seem to agree that part of the breaking in process in a violin is the subtle fracturing of the brittle hide glue that holds the purfling in the groove here, so that as the instrument is played, the vibrations tend to bust this glue in a very kind of subtle way. And then the top is freer to vibrate around the perimeter, which lights up the bass response and makes the instrument sound louder and more responsive in the low end. And I'm not sure what else to tell you about Frankentop, except that Frankentop has a new friend now named Elden Kelly. Elden, I just happen to have right here. And Elden loves this instrument, as we just found out. And
we call it Frankie now.
Frankie instead of Frankentop. Frankentop is too formal. Elden, say hello to the nice people.
Hello, folks at home, YouTube, fans of Archtoppery. We've got Labella 900 on the EA and D, and a Hanebach Chrome super high tension wound third G, and D'Addario extra hard tension B and E. Three sets to rule them all.
I understand that this is fairly common in the world of classical stringing.
Those just happen to be the basses that I like, and I like D'Addario trebles. And your suggestion was higher tension, which I think was good for the treble. The wound G was at first out of necessity with our nut width of this neck, which is considerably thinner than any classical nylon string nut width I've worked with. But I'm getting used to it, and I kind of like it. But it turns out the G kind of blends, I think, the basses and the trebles.
Okay.
Sonically.
It's a crossover.
Yeah. And I think, tell me what you guys think.